Okay, this seems late. We're going to talk about lines today. Why does this seem late?
That all the other three-dimensional objects that now going to one-dimensional.
Yeah, because this is like, what, 7 weeks into Calc 3, and we're like talking about lines today? Okay, so this didn't have to come here, but your book does, like, they do directional derivatives first, right? And then they do, like, integration stuff. And then next they do parameterized curves. And this section didn't have to fit here, but we can put it here anyway. So here's the idea of a line in Calc 3. First things first. Lines look like this, right?
Yeah.
Oh yeah.
There are one.
I mean,
You guys see that? Like, they're a one-dimensional object, right? So I want a way to take one dimension and stuff it into R3, right? Everybody good with this? Okay. In order to accomplish this in the easiest possible way, I'm going to put a vector hat on here.
Yep.
That is simply for ease of use. Okay? So, here's my idea. I'm going to think to myself, here's R3. Right? Okay. Here's some point in R3. Creatively, I'm going to call that x naught, y naught, z naught. Everybody dumbfounded by this? Cool, good, good talk. And then I'm going to say, I want to go that way. Oops, that's bent. Don't bend your vector. Why should this not be bent?
straight lines, one-dimensional.
Because it damn well better be a line, right? Keep in mind, not all one-dimensional things are lines.
Okay.
But this one should be a straight one-dimensional thing, hence a line. You guys all good with this? So I want to go in that direction. When I talk about going in that direction, we're going to accomplish this in the exact same way we would if we were teaching this to Algebra 1 students. Right? So we're gonna think to ourselves, in Algebra 1, a line was y equals mx plus b. Right?
But b in this case is going to be 1.
Wait, hang on. I am going to take one thing away. First thing I'm going to take away is y. Right? I'm going to call it L of x, and we'll argue about what category of object that is here in a minute. Okay? The x is still going to be my input variable. That's going to be my one-dimensional thing. But now I need this stuff to be stuck into R3, right?
B should be x naught.
Close. Let me see. I maybe give myself a little more space. Okay. X. I probably shouldn't use x here. I'm going to use x here, but it's going to be confusing. That x is not the other x. What's this stuff?
Starting position.
Yeah, that should be the spot you start, right?
Yeah.
Where are you starting? Okay. Let's get that x out of there. It's a terrible idea. Why would you guys let me do this? So we already used x for something, so I'm going to take the x out of here. What are we going to use instead of x?
T.
T. Sure. Okay. What should go here?
Our new.
Yeah, that should be m, right? That should be my slope. Okay.
mx, my.
Oh, I didn't really tell you what this vector was, right? I just said, like, there's some vector. That's a direction. let's give our vector direction a name. We'll call it ABC. Cool. Okay, so that maybe goes in here.
Oh.
Okay, so I wrote a bunch of shit down, right? Like I just made something up. Now let me check and make sure this makes mathematical sense.
See, ABC is a vector,
Yeah, so
and T is a variable.
ABC is a vector, T is a scalar, right? So this whole object is what kind of thing?
This is a vector.
It's a vector that I got out of doing scalar multiplication to a vector. Okay, so hang on. So this was a vector. This was a scalar. So this whole thing here is a vector. What's that thing?
Points. Where's that a vector as well?
That's a point.
This is where the parentheses in your book get you, right?
Yep.
That's a point, but what would I like to do with it?
Treat it like a vector?
I want to add it to a vector, right? So instead of thinking about it as a point, I'm going to think about it as a vector. Okay, which changes the picture I drew at the beginning, because I said dot, right? And what I needed was vector. You guys see that? So to get to someplace on my line, apparently I should go out to the x naught, y naught, z naught vector, and then out along the slope. What's this thing represent in that case?
The distance traveled.
Yeah, it's not quite the distance traveled, but you want to think about it as the distance traveled, right?
Yeah.
It might be the amount of time you spent walking.
Right.
Yeah.
You guys see that?
Right.
You guys cool with that? What category of object is L then?
A vector? Oh, wait, time. Vector based on time?
Yeah. You guys with me on that? This thing here is a kind of beast that I don't think we've seen before. Right? What is this thing?
Oh, a function of vectors.
How am I able to call T a scalar? That's a good question. T is just a one-dimensional variable, right? So the fact that it's one-dimensional means that it's a number, right? It's a number I don't know. So it's like an unknown scalar, right?
Wasn't it changing as a variable?
Yeah, it is. But it's still a scalar, right? It's one-dimensional. I know how to multiply one-dimensional things by vectors. Yeah, you're right, the result here. So maybe if I wrote this more honestly, I would be writing, this is a vector, it's AT plus X naught, comma, BT plus Y naught, comma, CT plus Z naught, right? You guys with me on that? So you're right, this thing's a little bit funky because it changes depending on that T variable, right? And that's what I mean by this is a beast we haven't seen yet. So if you had to call this something, what would you call this?
A vector based on scalars?
Yeah, so I think you have a better word for based on scalars.
How about a vector function?
What a vector function.
Yeah, vector function.
So this is sometimes called a vector function or a vector valued function. The reason we would put the word valued in there, right, is that we value this object. No, it's that the values, right, the outputs are vectors. You see that? Personally, what I would write is this. I would write L maps R to R3 as a vector space. But if I wanted to say that to someone, I would say L is a vector valued function. I might even say L is a vector valued function of one variable. You guys see that?
I remember.
Yes.
Gosh. Ace.
You definitely could have it of two variables.
That would just be, well, that wouldn't be a line.
It would not be a line anymore. It would be bent. Well, or at least it wouldn't be a line. It could be a plane, right?
Okay. Yeah.
It would be locally two-dimensional shape. This thing, right? Anytime you write down L mapping R into R3 as a vector space, that's going to be a one-dimensional object living in R3. That does not have to be a line. You guys with me on that?
Okay.
Like,
It's not exactly a function, but
this is a one-dimensional shape that even lives in R2, right?
Yep.
And don't tell me it's not a function yet.
Absolutely.
Okay.
Because
Oh, because we don't have.
what's the vertical line test look like here?
Oh my gosh, it looks exactly. Oh.
So the vertical line test, right, is testing for different inputs. How many outputs are there, right?
Yeah, and
Is
we
it that?
can't exactly prove that those are all.
So what that would mean here, right? So let me write down the vertical line test. So the vertical line test, right, means
If an input has more than one outputs.
yeah, right?
Yeah.
You guys see that? So like, if A has, I mean, it doesn't even make sense to write down.
It's just in the output.
You guys see that? Like, if I write, if A has F of A and F of A that are different,
Yeah.
you guys see that? Right, so I need a better method for writing this down. But really what it amounts to is two inputs that give different outputs, right? Sorry,
Or an input that
an
gives
input that has
multiple
two outputs.
Yeah.
An input here is a time, right?
Okay, so.
So as long as I'm not in two places
Okay,
at
so if
the
the line
same time.
splits, we'd have the problem. But the fact is, as long as it's a single line.
Yeah, you guys see that?
Yeah.
He's right about the splitting. Like if I'm drawing it like this, right? Like I'm saying these are one thing and then they go like that. Now I'm failing the vertical line test, right?
Okay.
But that's weird. You guys with me on this? This is a way you can get those graphs, right? That you're kind of not allowed to say are functions in Calc 1 or Algebra 2 or wherever. Like it's kind of like a circle or something. You can think of a circle as the graph of a function as long as you're willing to say, well, we'll just go around it in time instead of in x values.
So.
You guys cool with that? Okay, so these are lines. This is what I want you to know about lines. Lines look like this. In general, a vector value function could look a little bit weirder. So in general, a vector valued function looks like, say, v of t. And I really should put a vector hat over this thing, right? Because the output's going to be a vector. Could look like x of t, comma, y of t, comma, z of t, where x, y, and z are functions of one variable.
In those, in what you had before, like AT plus X naught, BT plus.
Yeah.
Those were.
Yeah, those are
lines.
each one-dimensional lines, right? You guys see that? When I wrote that L of t down, I had this thing. Each of these was linear in t. And so the result is, of course, linear in t. You guys with me on that? But if I had not linear in t in one of those slots, I would get not a line, right? You guys cool with that? I said that just now, and there's a small caveat to that, which is, what if you add like t plus 2 minus t plus 1 and 0? Is this linear in, is the z function linear in t?
Yes. I believe
Yeah,
it is.
It's like sublinear, right? It's constant. So up to interpretations of linear. This thing is still a line, right?
Yep.
You guys see that? Where does this one live?
The X, Y, Y.
Yeah, this lives in the XY plane, right? Wait, isn't a line in Calc 3 that lives in the XY plane, isn't that a cylinder? Like, isn't that a plane?
Oh, but this one, we specifically state z equals 0.
Good, you guys see that? This is how you get to actual lines, right? You have to specify that and z is 0 or and something about the third variable there. This is how you do it. Cool?
Okay.
You guys see that this contains just a tiny little bit more information than your usual line,
Yeah.
right? Because this tells you when you're at places, which is cool, you know, like actually usable in space and stuff.
Yeah.
That's the one that says negative t plus 1, right?
Yeah. Although it doesn't really matter, right? Just an example. All right, cool. Ready, set, let's call it a day.
Yay.